Hi everyone, welcome to this tutorial on my channel. Here we're going to use the difference of squares identity to simplify this rational expression. And then later on we'll use the difference of cubes identity to be able to solve this equation. The difference of squares identity. If we have the square of one quantity minus the square of another, then it is identically equal to the first one minus the second into the first one plus the second. Okay, this is the identity that we're going to use to simplify this rational expression. So when we look at the numerator here, we have x squared minus y squared. X squared minus y squared is a difference of squares. So x will play the role of a and y will play the role of b. So let us transform the numerator into the right hand side of this identity. And so this expression here will be written as x minus y into x plus y. Now, when we look at the denominator, we see x squared minus xy. X is common in the both terms. There is x here, there is x here. So x can be factorized out. If we factorize out x, then we're going to have x minus y. Now, here we have x minus y cancels out x minus y. And so we are left with x plus y all over x. Pay attention at this level. Don't make the error to come and say that we will cancel x here and cancel x there. That is not allowed. That is not allowed. Cancellation is allowed only when we can cancel each and every member of this expression. Cancellation goes here, and there should be something here with x by which we are going to cancel. If there is no x here, then cancelling this and this alone is not allowed. It is not correct. So this expression is the simplest form of that expression over there. Coming now to difference of cubes. The difference of cube identity says that if we have the cube of one quantity minus the cube of another, then this is the same as the first one minus the first into a squared plus ab plus b squared. This is the identity that we're going to use to be able to simplify the left-hand side of this equation. Again, when we look at the numerator here is actually a difference of cube because we can rewrite it as x cube minus 1 cube all over negative. Look at the denominator here. We have each term here is multiplied by the negative sign. So negative can be removed outside, and then we have negative into x squared plus x plus 1. Okay, the numerator here now is clearly written here, and we see that it's a difference of a cube. So we can now use this identity. We can use now this identity to transform the numerator. And so when we use the identity, we'll have x minus 1, okay, for this part. And then here we'll have x squared plus x times 1 is x plus 1 squared, which is 1. All of that divided by negative into x squared plus x plus 1. Okay. Now, this quantity here is the same quantity there. That cancels off. This minus sign here, we are going to have x minus 1 all over negative. Now, negative in mathematics is the same as negative 1. All right. Now, dividing by negative 1, the negative can also be taken up. All right. This simply means it goes up there, it becomes negative into x minus 1. Pay attention, it was an equation equals to 2. All along, we have been simplifying by the left-hand side. So, we can now complete the equation in order to be able to solve. This negative has gone up to bring us this new expression. So it is negative into x minus 1 equals 2. When we open out the bracket, that's going to give us positive 1 minus x is equal to 2. Pay attention, we're solving for x. So to have positive x, we just carry this negative x to the right hand side and take this positive 2 to the left hand side. So we have 1. This positive 2 coming this way becomes negative 2. This negative x going that way become positive x. Okay, so we have negative 1 is equal to x. So actually, the value of x is negative 1 in this equation.